Welcome to this deep dive on Amazon DynamoDB, one of AWS's most powerful and widely used services. In this video, we'll cover everything you need to know: what DynamoDB is, how its data model works, its core features, when to use it, and how it's priced. Whether you are preparing for the AWS exam or building your next cloud application, this video has you covered. So let's get started. DynamoDB is Amazon's fully managed serverless NoSQL database. You don't manage any servers, patches, or clusters. AWS handles all of that for you. It was built to deliver consistent single-digit millisecond read and write performance, no matter how much traffic you throw at it. Some of the biggest names in tech rely on DynamoDB. Amazon itself uses it to power the shopping cart during events like Prime Day, and Disney Plus uses it for streaming, and Capital One uses it for its financial workloads. The three pillars that define DynamoDB are its blazing performance, a truly serverless model, and built-in resilience through replication and availability zones. Before we go any further, let's get familiar with the core vocabulary of DynamoDB. So a table is your top level container, similar to a table in SQL, but without a fixed schema. An item is a single record inside a table. Think of it like a row, but each item can have completely different attributes. And an attribute is a key value pair within an item, like a column. But only thing is it's flexible here. Not every item needs the same attributes. And the partition key here is mandatory. DynamoDB uses it to physically distribute your data across storage nodes for scalability. The sort key is optional. When combined with the partition key, it allows you to sort and query multiple items that share the same partition key. And indexes, we have two different types of indexes, the GSI and the LSI. It lets you query your data using different access patterns beyond the primary key. We'll cover these details shortly. So let's look at what a DynamoDB table actually looks like in practice. So in this example, we have a users table with a composite primary key, user ID as the partition key, and timestamp as the sort key. Notice that user 001 has two items, one for January and one for February. The partition key is the same, but the sort key differs. So grouping related records under one user. The most important thing to notice here is schema flexibility. Each item can have different attributes. DynamoDB doesn't enforce a rigid column structure like the relational database does. When designing your table, always think about your access patterns first. DynamoDB is optimized for fast lookups like primary key. So your key design directly impacts performance. So DynamoDB gives you two capacity modes, and choosing the right one can significantly affect your costs. On-demand mode is pay as you go. You don't pre-configure any capacity. DynamoDB automatically scales to handle your traffic. This is ideal for applications with really unpredictable traffic, or even bursty workloads at like event-driven systems. The trade-off is a higher cost per request. So provision mode requires you to specify read capacity units and write capacity units upfront. You pay for what you reserve, not for what you use. This is the most cost effective for steady, predictable workloads. And you can enable auto scaling to adjust capacity automatically. Start with on-demand when you are prototyping or early in development, then switch to provision once your traffic patterns become predictable. Now let's see what global secondary index and local secondary index are. So the secondary indexes lets you query DynamoDB using attributes other than the primary key, which is critical because DynamoDB only supports key-based queries natively. A global secondary index or GSI, it gives you a completely different partition key. It spans all the data in the table and has its own separate throughput capacity. You can create up to 20 GSIs per table and you can add them at any time. They support only eventual consistency. A common use case is querying users by email ID even though the table's partition key is a user ID. A local secondary index, on the other hand, keeps the same partition key as the base table but uses a different sort key. It shares throughput with the base table and supports both eventual and strong consistency. So the catch is LSIs must be defined at table creation time and cannot be added later. You are limited to 5 LSIs per table. So design your indexes based on your read access patterns before you write a single line of code. So the thing is, DynamoDB is more than just a key value store. It comes packed with really powerful built-in features. DynamoDB streams captures every item level changes like inserts, updates, and deletes as an ordered event value stream. This is the backbone of event-driven architecture and can trigger AWS Lambda functions in real time. Transactions bring ACID compliance to DynamoDB. Using transact write and transact get, you can automatically update multiple items across tables, critical for financial or inventory operations. Global tables let you replicate your table across multiple AWS regions with active writes. Users around the world get low latency access and DynamoDB handles conflict resolution automatically. TTL or time to live lets you set an expiry timestamp on items. When the time is reached, DynamoDB automatically deletes them for free. It's great for session data, cache entries, or audit logs. PartiQL brings SQL-like syntax to DynamoDB. If your team is more comfortable with SQL, you can query and manipulate data without learning the native API. An encryption address is enabled by default using AWS KMS. You can use AWS managed keys or bring your own customer managed keys for stricter compliance requirements. So let's talk about performance. DynamoDB is engineered for speed. It delivers sub 10-second millisecond latency at the 99th percentile, meaning even your slowest requests are fast. Storage is virtually unlimited and it processes trillions of API calls every day across all AWS customers combined. If even single-digit millisecond latency isn't fast enough for your use case, DynamoDB Accelerator or DAX is an in-memory caching layer that brings read latency down to microseconds. DAX is fully managed, highly available, and here's the best part. It's completely API compatible with DynamoDB. That means you don't have to rewrite your application code. Just swap the DynamoDB client for DAX client and you're done. DAX uses a write-through caching model. So writes go to DynamoDB first and the cache is updated automatically. So DynamoDB is incredibly versatile. Look at where it shines in the real world. Gaming is the classic use, leaderboards, player profiles, and matchmaking all benefit from DynamoDB's low latency and horizontal scalability. E-commerce platforms use DynamoDB for product catalogs, shopping carts, and order management. Systems that need to handle unpredictable traffic spikes during flash sales. IoT and time series workloads like sensor telemetry and device events generate massive amounts of data that DynamoDB can ingest and store efficiently. Serverless applications built with AWS Lambda pair naturally with DynamoDB since both scale to zero and charge only for actual usage. Content and meta stores like media catalogs or user generated content benefit from DynamoDB's flexible schema where each item can have different attributes, and session management is a perfect fit. DynamoDB speed and TTL makes it ideal for storing and automatically expiring user session tokens. Now let's compare DynamoDB to a traditional SQL database so you understand when to choose which. And for schema, SQL requires a fixed rigid schema defined upfront. DynamoDB is a schemaless items. Items in the same table can have completely different attributes. And for scaling, SQL databases typically scale vertically, meaning you upgrade your server. DynamoDB scales horizontally automatically without any downtime. DynamoDB supports its own API and the SQL like PartiQL, where traditional SQL uses standard SQL. Joins are not supported in DynamoDB. Your data model must be designed to avoid the needs for join, usually through denormalization. And DynamoDB is eventual or strong consistency, whereas SQL by default is ACID compliant. And the cost model is SQL databases are typically built by instance sizes and uptime. DynamoDB charges by request or provision capacity. And the bottom line is choose DynamoDB for massive scale, simple access patterns, and serverless workloads. Choose SQL for complex relational queries and strong transactional requirements. And these are the pricing. It's important whether you are using it for production or studying it for the AWS exam. In on-demand mode, you pay per read request unit and write request unit. Writes cost 5 times more than reads, which is consistent across most databases. Storage is billed at 25 cents per GB per month, with the first 25 GB free under the AWS free tier. That's a wrap on Amazon DynamoDB. Let's quickly recap what we covered. DynamoDB is a fully managed serverless NoSQL database. There's nothing to install, patch, or scale manually. It delivers single-digit millisecond latency at virtually any scale, making it one of the fastest databases available in the cloud. Its flexible data model supports key value and document data with no enforced schema. Its rich ecosystem, streams, DAX, transactions, global tables, TTL, PartiQL makes it suitable for a wide range of production workloads. And it's ideal for modern cloud native and serverless applications on AWS. If you find the video helpful, please like and subscribe for more content. Drop a comment below if you have questions, and I'll see you in the next one.